In this question, we are given the two functions g of x and h of x, and we are also given that there is a function f of x which lies between g of x and h of x. That is, f of x greater than or equal to g of x and less than or equal to h of x in the interval x greater than or equal to -1 and x less than 2. And we have to determine this limit, that is, limit of f of x when x approaches 1. So first, we are going to determine that if we can apply the squeeze theorem here. So for that, I need to evaluate the limits. That is, a limit of g of x approaches to 1, as well as this limit, that is, a limit of h of x when x approaches 1. And I need to check if these two limits are approaching the same value. Let's say if this is, well, that is, these two, the value of these two limits are equal to each other. And then we can say that according to the squeeze theorem, we say that the limit of f of x approaches 1, and this is also L. This is according to the squeeze theorem. So this is what we are going to do now. So let's start to find the first limit. That is, I'm going to determine this limit. So let me do that. This is the limit of g of x when x approaches 1, and this equals limit of, I replace g of x as this function, that is sine of pi by 2 x plus 4. This is for g of x approaches 1. So we can do the direct substitution here by plugging in x equal to 1 into the g of x. So when we do that, we get sine of pi by 2 times of x is replaced as 1 plus 4. And this gives pi by 2 times 1 is pi by 2. So it is sine pi by 2 plus 4. We know the value of sine pi by 2, which is 1. So this value is 1 plus 4, and this gives 5. So we found the limit of g of x when x approaches 1, and this equals 5. We now find the limit of h of x when x approaches 1. So let me replace the h of x, which is negative 1/4 x cube plus 3/4 x plus 9 half. This is for h of x and when x approaches 1. So now we can do the direct substitution because this one is a polynomial function. It is continuous everywhere. We will check when x approaches 1 by plugging in x equal to 1. So therefore this becomes negative 1/4 times 1 cube plus 3/4 times 1 plus 9 half. Let's simplify this. This is negative 1/4 plus 3/4 plus 9 half. We have a common denominator of 4 here as well as 4 here. Only this denominator is 2. So we multiply and divide by 2. So therefore this is basically 9 times 2 is 18 and 2 times 2 is 4. It is 18 over 4. So I'm going to replace that as 18 over 4. Let me remove and replace it here. So this is 18 fourths. Now we have common denominator, which means we can add the numbers in the numerator. That is negative 1 plus 3 plus 18, and this is all over 4, and this gives 18 plus 3 is 21. 21 minus 1 is 20. So we get 20 over 4, and this equals 5. So we found the limit, that is when x approaches 1, h of x approaches 5. So this is the value of this limit. We now see that the limit of g of x approaches 1 equals 5, and the limit of h of x approaches 1, this is also 5. These two are equal to each other, and we also know that f of x is squeezed between g of x and h of x. So therefore, according to the squeeze theorem, we see that limit of f of x when x approaches 1, and this value is also equal to this 5, because both the limits approaches 5, and this f of x is also approaches 5 when x approaches 1. So therefore the value of this limit is 5, and this is according to the squeeze theorem. So we can say that the value of this limit is 5. And so option C is correct.